So today we're going to mostly finish up with the material I want to talk about Chapter 6, which is classes. I have a couple miscellaneous odds and ends and other such sundry material to get to. We are going to start arrays maybe this Friday. If not this Friday, we're going to start it next Monday. I need to get it started next Monday because next week's lab is going to be on arrays, and then the homework that is due not next week but the following week is also going to be on arrays. So I need to make sure I move into the array chapter so that I introduce you to the material before I start having you do homeworks on the material. So that's how we're going to progress. We're going to eventually get through arrays and then come back and talk some more about classes. So let's see. Most analyses are pretty much the same as last time. Homework 8, we are currently editing it. It will definitely be ready on Friday. In fact, it's mostly ready now, but I'm going to spend some time talking about it Friday. There's 2 more classes that we're going to be developing for the game. Off the top of my head, I forget what they are. I think it's like Depot and, I don't know, something else. But I'll know on Friday. 1 week from today, I'm getting dunked, assuming it's not. So the weather for the next couple of days is going to be a low of 27 and 25, and they're expecting possible snow on Friday. I tell you right now that if it's like a high of 45 degrees on dunking day 1 week from today, I'm not getting dunked. They can bring the dunk tank here. Boo. I'm going to die of hypothermia. I produce like 0 body heat. I fall down into the dunk tank, I die. And then you all get Fs if I die in a dunking tank, just so you know. Speaking of grades, so I think I mentioned this briefly. I'll mention it again. The final exam is actually going to be optional in this class. I believe with 99% certainty. I haven't actually chatted with Professor Coe about it. The reason is I just don't want to grade the final exams, to be quite honest. Yeah. So, yes, I know. Yeah. So the thing is that, grading these exams takes a huge amount of time. Takes all my TAs a heck of a lot of time to do it, and my TAs obviously have other things to do in their lives other than, TA this class, and during finals week they're doing their own finals and are busy doing things. Then it ends up getting stuck on myself and Professor Coe, and I hate grading. I don't want to do any more of it than I actually need to. So what we do is I make the 3rd midterm conveniently the last Wednesday of the semester. So that ends up acting as a comprehensive final. We call it midterm 3 because I'm not allowed to call it a final if it's a week before finals week, so it's called midterm 3. But that's essentially what it is. And so this way, I can sleep soundly at night knowing that you have been fully tested on all your Java knowledge that you have or have not absorbed in this class. Then what happens is we take the final, and really I try to discourage you by taking the final, because, as I said, I really don't want to spend much time grading it. So the way it works is that you can choose to take the final or not. And we're going to talk about this more as it gets closer. If you take the final and turn it in, we will count that grade even if it hurts your average. So if you have a 90 average and you get a 20 on the final, you're definitely not getting an A in the course. It's because it counts as like 1/5 of your overall course grade. What you can do is you can show up, take a look at the final, and then decide that you really don't want to take it after all and rip it up and give us the confetti. And that's always particularly entertaining because the first 10 minutes as people look through the final, you hear all this tearing up, tearing up of the exams. So we're going to spend more time talking about it as we get near. But the second to last class is the midterm, and that midterm will be ready to be returned, again, probably like a day or so later. But the final itself will be optional. In the past, we've had about 10% of the class actually take and turn in the final, which works great. If 10% of this class turns in the final, we're going to have about 40 finals to grade and 20 people grading them. So, yeah, that'll work really well. So that's the final. Eventually it'll appear on the slides as sort of an official thing. But really, the way the course is designed is I design it, when I laid out the schedule, I designed it so that you would have a final testing exam, just not during finals week.
So if you don't take it, it doesn't count?
If you don't take it, then it will not count one way or the other for your grade. When you look at the view grade script, currently, for all the stuff that's been returned, about 44% of your grade has been determined. when the semester is all said and done, 80% of your grade will be the homeworks, the lab quizzes, and the midterms. The final would be the remaining 20% of your grade. So it's just not going to count one way or the other. What we will try to do, and I cannot guarantee this, but we will try to get everything returned in time, or let me say almost everything returned before the final is actually given, so that you can decide whether or not you want to take it to bump up your average or not. I will tell you right now that getting the last homework returned in time may prove very difficult, because the last homework is going to be due like only a couple days beforehand. So we will try to do that. There might still be an assignment or two outstanding at the time the final is given. I forget when the final exam schedule is. Does anyone remember offhand when the final is, or is not? I'm sorry? The day after classes are done? Oh. If it's the day after classes are done, then there's no hope of us getting everything returned to you in time. Like if it was the next week, then sure we could do it. But so we will try to get as much returned to you in time as we can. We won't have fully everything determined. Questions? Is there extra credit in this class? No. So I know I'm a horrible, mean old man. The question was, is there extra credit in this class? In general, this class has fairly high grades. People generally get, the average on the homeworks is mostly in the 90s, the average on the exams is in the 80s, which brings the average of the course into somewhere in the B+ range, which means that a good percentage of the class is going to be getting A's. And the engineering school would not be happy, although you would all love me for it, the engineering school would not be happy if like everybody got an A. So I can't really give extra credit because that's just going to boost up all the grades, and the engineering school gets mad at me and they fire me, and et cetera, et cetera. Other questions? Yes?
If the final isn't counted, would everything else count more? Would it be weighted more?
So if the final is not counted, so the question was, is everything weighted more? Currently, so the weightings, the numerical ratings will stay the same. The homeworks will still count for 30% of the grade. Is that what it is? I think it's 30%. So I'm not going to change the weightings if you don't do the final. What will happen is that only 80% of your grade will have been determined, not counting the final, and it just won't even consider the other 20%. So although the weightings don't change, really the homeworks then, instead of being so if you take the final, the homeworks are 3/10 of your grade, right? 30% out of 100%. If you do not take the final, then it's 30% out of 80% is your grade, which ends up being maybe 37.5. So everything sort of expands equally because the grade doesn't have the extra 20% in the final. But I'm not going to actively change the weightings for those who do or don't take the final. Some of the weightings, as I mentioned earlier, the weightings of the homeworks may change slightly. Those homeworks that were slightly harder and therefore required a bit more work might be weighted a bit more than the others. I'll still follow the syllabus in that the homeworks will still be 30% of the grade, but I might modify the weightings a bit here and there. Other questions, comments, concerns? Okay. So I wanted to spend a bit of time. Nope, that's not the right one. Yeah, I don't need that. So I wanted to talk about some stuff that actually is going to be fairly relevant for the homework. And maybe, possibly. We realized after we turned out the homework that there's a minor mistake we made in how we phrased it. So I want to actually explain it if PowerPoint ever decides to behave. Oh, there we go. Okay. So let's look at this class. Here we have class foo. Has a single instance variable x. And it has a single constructor that takes in some parameter x and sets x equal to x. And the question is, at this point in the code, which x are we talking about? Because there's two of them, right? There's one that's the parameter, and there's one that's the instance variable. Well, Java is going to consider that x to be the most recent x that's been declared. So if you look at this x, the parameter is declared within this block. This x is declared within this block. So you can have a series of x's declared in separate blocks, and Java will consider the most recent x declared, or the one in the most recent block. Which means that when you're setting x equal to x, really what you want to be doing is setting the instance variable equal to the parameter, right? That's the goal here, is that this constructor was called with, I don't know, 7, whatever you want, and you want to set this instance variable equal to 7. When you say x equals to x, you're not actually it starts getting confusing as to which one you're actually talking about, and Java has no idea which one you mean. So the question is, which x is being referred to in the constructor? And in the constructor, I don't mean the parameter. I mean that particular line that my nice pretty arrow is pointing to. So Java will always use the most recent x. In particular, it's not talking about the instance variable. What this code does is this sets the parameter equal to itself. So if your parameter is 7, it's going to set, so when this called x is equal to 7, it's going to set x equal to 7. Which it already was before, which is probably not what was desired.
So now when you wrote x equals x, which one is the instance variable and which one is that most recent?
This is the instance variable?
No. I mean, like, out of those two, when you're doing x equals x.
Right. This is, both of these are referring to the parameter. So that's the problem, as it's stated right here, is that both of those x's are referring to the same variable. It's not setting this variable equal to that one. It's setting the parameter equal to itself. And this doesn't really do much. So when does this come up? We're going to see public person, and its parameter is string name. Right? This is in your homework. And in this class person, so you have your class person, you have a string name already, which is the name of the particular person. And what you can't do is you can't say name equals name. Now, if you can understand my chicken writing, it's essentially the same thing. You have a variable, an instance variable called something, in this case name, and your parameter to the constructor is called the same thing. So if I just say name is equal to name, it doesn't really do much. Just as I have an instance variable x, and I have a parameter x, if I say x equal to x, Java has no idea which one I'm talking about. So this is where it's going to actually come up in the homework. So it turns out that there's a couple ways to solve this. So I'm going to modify the class, and the one modification that I've made is, so far, is the line that is yellow. And the line that is yellow says this.x equals x. So if I just say x, Java's going to look at the most recent x, and it's doing the parameter. This.x means the x that is an instance variable of that particular object. So anytime I say this.x, that always, always, always is going to refer to the instance variable. This is a keyword in Java. It actually does a number of things. And there's a number of, I guess, sort of overloaded things that it can do. We haven't really seen the rest. But in this context, in the particular context that's on the slide, it's saying from this particular object that this is being called out of, I want to use the x instance variable. So that's one way to get around it, is you're saying specifically set the instance variable equal to the parameter and not the parameter equal to itself. So this.x refers to the instance variable. X all by itself refers to the parameter. This does what we want it to do. Here's another way to solve it. I'm just going to rename the parameter. I'm going to name the parameter y. So now there's no confusion. X, there's only one x there. It's the instance variable. There's only one y there. It's the parameter. And I just say x is equal to y. And this way, Java knows that x is talking about that x, y is talking about that y. Everything's hunky-dory. So we can also rename the parameter to something else, and it still works. So in your person constructor, you could call the parameter string n and say name is equal to n, for example, or something along those lines. Either one of these will allow you to get it to work. Questions on this? How many people felt they understood it? Okay, I'm seeing a good number of hands. What we should have done in hindsight is we shouldn't have named the parameters to the constructors the exact same name as the fields. That's done in practice, but being as we hadn't gone over the this dot notation yet, In hindsight, we shouldn't have done it. Obviously, it's too late to modify the homework at this point. So that's how you get around it. So I wanted to spend a bit more time talking about staticness. Remember we declared a class circle. We started talking about it a couple weeks ago before the exam. And in our class circle, we had two fields. One was radius, and every circle has its own radius. And one was pi, and pi was declared static, which means that no matter how many circle objects I declare in memory, each one has its own pi field, and there is one and only one. No matter how many circle objects I declare in memory, everyone has its own radius field. There's only one pi field in that particular, no matter how many objects I declare. So consider this particular method, double get pi. For whatever reason, let's say we wanted to get the pi field. I'm going to show a more convincing reason why we'd actually need a accessor for a static field a bit later on. But let's say we had some particular some particular method that just returns a static field, or a class field, class variable, static variable, whatever you want to call it. This doesn't care which object it's being called out of. If I declare 5 circle objects with different radii, 1, 2, 3, 4, 5 are the different values of the radii, and I call getRadius, it matters which circle object I'm calling it out of. C1.getRadius is going to give me 1. C5.getRadius is going to give me 5. They're all going to give different values depending on which object I'm calling it out of. This doesn't. There's only one pi field, right? It's static. So it doesn't matter which circle object I call it out of, it's still going to give me the exact same value, which is the value of a single pi field. So it doesn't care about the object it's being called out of, because it only deals with static fields. So it doesn't rewrite the radius. The radius in this example was the only non-static field out of 2, was the non-static field in this particular whole discussion. So the other thing to keep in mind is this method couldn't care less about how many objects are declared, because there's still going to be a pi field. Even if you declare 0 circle objects, there's still a pi field. This gives you that particular value. So what we're going to do then is we're going to make the method static. And what the method static does is it says that method doesn't care about any such objects that have been declared. Now, getPi is static, so it still returns double. It's a static method. It couldn't care less if you've declared 0 circle objects, 1 circle object, 4 circle objects, or 1,000,000 circle objects. There's still only one pi field, right? In each of those 4 scenarios, there's still only one pi field. That's what this method is going to return. In particular, a static method can only access static fields. Think of the situation when you have 1,000. Think of the situation when you have 0 circle objects declared in memory. You've not created any circle objects, but if you remember from the static field discussion, pi is still hanging around waiting to be read. You can still call this method and get that value of pi, but there aren't any circle objects yet declared, which means that you cannot actually call or access a non-static field, because there aren't any non-static fields yet. We have not declared any circle objects. There's no circle C because new circles. None of that's been defined. All we want to do is just get the value of a static field. We're going to call a static method. We're probably going to say circle.getPi. And it couldn't care less about any objects that are declared. So a static method cannot access a non-static field. Consider math.cosine. That's a method that we've seen, we know, we love, whatnot. It turns out that there aren't any math objects declared in memory. So nowhere in the Java SDK did it actually declare a math object. There is a math class that was defined somewhere, and it has a whole series of static methods. And one of those static methods is cosine. Cosine doesn't care about the math class. All it cares about is whether or not the angle that's given in, 90, and it's going to spit out the cosine. 0? Yeah. So there, the cosine method doesn't care about any math objects that have been declared. Maybe there is a math object that's been declared. Maybe there isn't. It doesn't matter. Any method that doesn't care about any objects or about the object that it's part of. So let me try that sentence again. In this case, the cosine method doesn't care about many math objects that are declared, so it's a natural candidate for a static method. Right. Doesn't care about any objects. A lot of the methods in the math class are methods that do this. Right. So, static fields, we can say, so say now we've declared a circle object. Circle C equals new circle. I can say C.pi. I can also say circle.pi. Because there is only a single pi field, I can say class name dot field name. I can do the same thing with static methods. So let's say I do actually create a circle object. I can call c.getPi. That's saying from that C object that's declared, call the getPi method. It still returns the one and only pi field in memory. I can also say circle.getPi. That's saying from the circle class, call the getPi method. That's still going to return the one and only static field. And we've seen a lot of both static fields and static methods. System.out.println. Well, no, actually, that's a kind of bad example. In the math class in particular, we've seen quite a lot of them. String.valueof. If you remember when we called the valueof method, we could have created a string s and called s.valueof. But we also called string.valueof. We said from the string class, call the valueof method. Because the valueof method doesn't care about any object that's called out of. If you're calling substring, it makes a big difference what string object's been created. Valueof doesn't. It takes in the int 52 and is going to return a string of 2 characters, a 2 and a 5 in the other order. So static methods are also called class methods. You'll see that terminology used both ways. So consider this circle method, getRadius. I have now made getRadius static. And all it does is it returns the radius. So it's just like the getRadius we saw before, but it returns the radius. And this is the code to invoke it. I create 4 circle objects, each one having some radius. And then I call circle.getRadius. And the question is, which radius does it want to return? So remember that radius is non-static. It's an instance variable. And here we're calling it out of a static method. So when I sit there and I create 4 circle objects, and then call circle.getRadius, it's unclear which radius needs to be returned. So that's what memory looks like. In this case, all the radii are the same. We could have easily made them all different. And circle.getRadius, Java doesn't know which one you actually care about. It doesn't know which radius to return. Because you're trying to access a non-static field from a static method.
So does it not compile, or does it get an error?
This will not compile. Java will actually prevent this from compiling. If you declare a million of them, same thing. There's a million circle objects. Java doesn't know which one you actually mean. And if you declare none of them, no circle objects, it's still a pi field, but you can't call getRadius or static getRadius method because there aren't any radii declared. So the things to remember about static methods. A static method cannot access an instance variable of that particular class. It can only access static variables of that particular class. So you'll notice that in some of the code that we've seen so far, such as the game.java code, in our public static void main string args, so keep in mind that main is a static method, it accesses a number of variables that are defined above. All of those variables are also static variables. We did static, what was in the game.java that we gave out? Max health. Public static final int max health equals 10. So it's static which is what we're talking about. Public, anybody can access it. Int, it's going to hold an integer value. Max int, it was all caps because we made it final, equals 10. Because it was a static field, it could be accessed within the main method, because main is a static method. So there are a total of 4 rules that one needs to know when you're dealing with static and non-static. Non-static fields and non-static methods can only be accessed by the object name. If I have a radius, so every circle has its own radius. And if I want to find out the radius, I need to say from this particular object, give me the radius. Whether I call the getRadius method or the just access radius field directly, that doesn't matter for this particular rule. So a non-static field, such as radius, can only be accessed by the object name. I can't say circle.radius because it's unclear which radius we're talking about. Static fields, on the other hand, can be called either by the object name or by the class name. I can say c.pi for some circle c equals new circle I've created, or I can say circle.pi. Non-static methods, such as getRadius, can refer to both. Another example is compute area. Compute area is a non-static method, and it returns pi r squared. So pi, which is a static field, times radius again, it accesses both static and non-static fields. Whereas a static method can only access static fields. All right. How are we doing with staticness? It's working today. Okay, so that was actually that's better than I had feared. That's actually pretty good. I realized that I sort of threw all this at you fairly quickly in terms of the static methods. We're going to be reviewing this as the semester continues, so that's actually quite fine for now. So Despair.com came out with the demotivators, and I think I showed you the demotivators that a student in the class 2 years ago had created. These are also some rather unofficial demotivators. And as you can see from the first one, I had to wait a week or two to give it. Futility. Knowing that a freshman is handing you your rear in your last game in front of your parents and there isn't a darn thing you can do about it. Chances. Don't be a wimp. This guy seems legit. Mostly sunny in 72. Consistency, being assured of putting in the same effort, the same intensity, the same passion, and getting the same losing hug in March. Yeah. I've seen a lot of other unofficial demotivators. Most of them would probably get me fired if I showed them. Yeah. Or that I'm not showing them, or that I'm not being fired. Both. Okay, so let's talk a bit about our main method. In the beginning of the semester, day 1, well, day 2, day 1 was talking about the course structure. I said public static void main string bracket args. Memorize it. We're going to be using it in pretty much every program. Now we've seen a good amount, not quite everything, but we've seen a good amount of it. Public means any code anywhere can call that main method. Static means it can access a non-static field of that given class. And it can be only it can be called by the class name, if we so want. Void means it doesn't return any value. Main, of course, is the name of the method. The string bracket args, that's something dealing with arrays. we're going to start seeing arrays next week. An array is sort of like a vector. It's a list of things or a container or however you want to look at it. We're going to start talking about arrays next week. So we've seen a good amount of this, all the stuff for this main method. This is one of the things that frustrates people who are teaching Java, because on day one I have to say public static void main string bracket bracket args, and it's not until 3 months into the semester that I actually finally get to explain what half of that stuff means. I've actually been pushing to change away from Java. That's not going very well. So the fact that main is a static method has a number of implications. It can call other static methods within the same class. Here we have some static methods class. Main is static, method 1 is static, and we can happily call method 1. Notice that we didn't have to say static methods. I'll do static meth. Static meth.method 1. I did not have to say class name dot method name. I could have. But if you don't specify a class or an object in front of a method, it just assumes you're talking about the one in that particular class. So being as I just said method 1, it's assuming that it's a particular method in that given class, and it's going to call that method there. And not surprisingly, that prints out hi. So you may say, why do we care about static methods? Oh, question?
You said you were trying to get away from Java.
Yes. I would like 101 to not be Java.
What would you like 101 to be?
I'd like it to be Python. Python can teach almost all of the same concepts as Java, but you don't have public class, hello world, public static void main string bracket bracket args, system.out.println. There's sort of a lot of extra syntax and a lot of things that make teaching Java very difficult, because I have to spend so much time saying, memorize this line, you'll see what it means 3 months from now. And I think that it frustrates me as an educator, because it's actually, these intricacies of the language hinder my ability to actually teach it, because I'm saying, memorize this, I promise you'll see what it means 3 months from now, instead of just something like print or something really simple. Java is great for doing, sort of advanced programming. Personally, I don't think it's very good for doing intro to education. You may ask, well, why the heck are you doing this? Well, it's not my choice, really. Turns out there's 4 committees it has to go through in order to get change. It has to go through the CS curriculum committee, the CS faculty, there's a Cs committee, and then the Cs chairs, and there's a lot of resistance to changing it. Luckily, although this really doesn't affect any of you, there is mounting evidence that Java is not the most perfect language to teach intro programming in. So I do think it will be changed, which is not to say everything we've been doing is a waste. It's just that I think that you will have learned quite a lot of programming in this class. I just think I could have taught you a bit more if it was not in Java. So, but again, I've been arguing for changing Java for quite some time. It's politics. I mean, academic politics, some say, is worse than governmental politics, and so there's a lot of resistance to it. That's my rant on Java. They asked me to grade the AP exam, which is in Java, and I just sort of laughed. So, another example of using static methods. Let's say we want each circle class to have a unique ID. Well, if we were creating cars in some world, like we had some game or some transportation simulation, we could easily want to give each car a unique ID. Your car, if you have one, has a VIN number, right, which is some 27-digit number that uniquely identifies your particular car. If you were creating car objects, you could easily want to give them unique identifier numbers as well. I'm going to say I'm creating a circle class, and each one is going to have a unique number. It doesn't matter what it is, as long as it's different than any other circle object that's created. So I'm going to say the identifier will just be a positive integer. 1, 2, 3, 4. It's just going to create them in sequence. If you declare 1,000,000 circle objects, you have IDs 1 to 1,000,000. So in the circle class, I'm going to add an instance variable or a non-static variable into ID equals 0. Remember now, every circle class is going to have its own radius, which can be any value you want, and its own identifier, which is going to be consecutively numbered positive integers. And so for every circle object we create, we can have our own, each circle object is going to have its own ID and its own radius. So the thing is that when we get around to creating an object, we need to figure out what is the identifier or the unique ID being assigned to this particular object. And we can't just always assign it the value of 1, because then all the circle objects have ID 1. It's not particularly unique at that point. So what we're going to do is we're going to keep track of the last assigned identifier number with a class variable, which means there will only be one instance of that variable, and it's going to keep track of the last number assigned. If 9 was the last number assigned, the next circle object created gets 10. If 15 was the last number assigned, the next circle object gets ID 16. So static int last assigned ID equals 0. So now the circle class as defined has two instance variables, radius and ID, and has two class variables, pi and last assigned ID. Right. Just like pi, there's only one pi field. The last assigned ID is shared among all the circle objects. So when I create a new circle object, I can access the already created last assigned ID field because last assigned ID is static. So I'm going to create a method that will give me a unique identifier number. That method looks like this. Public static int get ID. So get ID because it gets a unique identifier number. Int, it gives us an integer. Public, why not? And static because we're only going to be dealing with static variables, as you see. And that's the method. It increments last assigned ID and then returns that value. Initially, last assigned ID is 0. This turns that into 1 and returns 1. Next time it's called, it makes last assigned ID 2 and returns 2. Then 3, et cetera, et cetera. Every time this is called, it increments last assigned ID and returns that new value. So it's always going to return a different value every time it's called. It will never return the same value twice. Yes?
So don't we want it to return the same ID if we're talking about the same circle?
I see where you're getting with that. Let me get back to that in a second. So, right, the method is static. So in the constructor, we're going to put this particular line, ID equals get ID. When the circle is first created, I'm going to assign it a unique ID. So what I probably should have done is said this is actually called unique ID. So it's actually called get unique ID. So in reality, the get ID method, and I'll actually change the slides for this. We would have an int get ID method that just returns the ID field. So that method is non-static, and it gives us the ID of that given circle. That will return the same value every time. If your circle has ID 27, every time get ID is called, it's going to give you 27. But get unique ID is called to assign a new unique ID to a given circle object. Whew. So I'm actually going to change that in the slides. Any questions on this? All right. Let's go over some semi-more official demotivators. Dysfunction. The only consistent feature of all your dissatisfying relationships is you. No, that's not one that I would hang up in my office. Despair. It's always darkest just before it goes pitch black. I think I do have that one in my office. Intimidation. No one can make you feel inferior without your consent, but you'd be a fool to withhold that from your superiors. So we've talked about the meetings one. It's a bunch of hands holding each other and says none of us is as dumb as all of us. I have a meetings mug, which I bring to all my meetings, and I'm sitting there in the meetings, and I sit there because my view of meetings is the more people in the meeting, the less gets done. And we have these meetings with all these people, and nothing gets done. Everyone argues, politics, all that fun stuff. And I sit there and I rotate this mug so that people will notice, like, what it says. No one's noticed. I've pointed it out to people a couple times, but no one's noticed my somewhat silent revolt at having to go to meetings. So I'm sitting there, and I'll sit there and I'll rotate it. A couple minutes later, rotate it again. Someone had a question. No? All right. So you can get like half a dozen different demotivators as mugs. I just think this is the best one. All right. So I want to spend some time talking about how to debug Java code. Maybe I should have gone over this a bit earlier in the semester, but some of the stuff, well, I'm magically going to tell you how to debug all of your code all at once. Let's look at this particular method. The particular thing I'm going over here deals with methods calling other methods. So here I have my main.java. Public static void main, string bracket bracket args, or string args bracket bracket. It actually doesn't matter where the brackets go. Error E1 equals new error 1. Not surprisingly, that's going to create errors. E1.foo, E1.bar. And in my error1.java, I have a constructor that's a do-nothing constructor. I have a foo method, and I have a bar method. Bar method is easy. It just calls foo. The foo method creates a string s, sets it equal to null, so it creates a reference, but makes a point to null, does not create an object. And then I call s.substring 5. Who sees a problem with this? Remember that if you have s is a reference pointing to nowhere, and you say s.substring, that starts at s, dot means follow the reference, call the substring method out of what it points to, or the object it points to, but it does not point to an object. This is going to give you a null pointer exception. Is everyone okay with that? All right. So, right, there's the problem. And of course, if we call bar, then bar calls foo, and foo crashes. So this causes a null pointer exception. And if I was to actually run it, this is the output it gives me. Exception in thread main, java.lang.null pointer exception at this, oh, I'm sorry. Ignore that. Right. Okay, let's try it that time. And it basically gives this somewhat cryptic output. So, this is the error output. Exception in thread main, java.lang.null pointer exception at error1.foo, and it gives that, and at main.main. So, a couple things that this is giving us a number of things, information. The first line tells us what happened. A null pointer exception is Java's way of saying that you tried following a null reference. There's class cast exception. I mean, basically any error that occurs, Java's going to tell you what it means. A null pointer exception means that somehow, somewhere, you tried following a null reference. This tells you that the particular error occurred in the error1.foo method. So the error1.foo method is the method that blew up, or that caused the problem. It's line 6 in the error1.java file. That line says that this error1.foo method was called from main.main, main.java.for. In other words, line 4 of main.java, which is the main method, calls error1.foo, right, e1.foo. And line 6 of that is what actually caused the error. So the first two lines are really the most important, right? The first line tells you what happened. The second line tells you exactly where it happened. Any successive lines then tell you how it was called. So if I go back to my code, here this is my main method. This is line 4 of my main method. That's calling e1.foo, and then line, 6 of my e1.foo, I'm sorry, my error1.java, that's where the null pointer exception actually occurred. So then what we do is, beep. So let's comment out the e1.foo in our main method. So now this is what it looks like. Error1 stays the exact same. Now this is going to call e1.bar. E1.bar calls foo, and then foo still crashes. So go to main, comment that puppy out. Oh, that was quick. And now when I run it, it has a slightly different error message. You'll notice that this is one line longer. So that error message looks like that. What this is saying is, still it was a null pointer exception that happened, or you're following the null reference. This is the exact line that null pointer exception occurred. Line 6 of error1.java, that's what's in parentheses, and it happened to be in the error1.foo method. That particular method was called from error1.bar, so the bar method called the foo method. And line 10 of error1.java, which is in the error1.bar method, called the foo method. And then that bar method was called try the main method in the main class, and that's on line 5. So this is basically telling you what method called what other method called what other method, and it's called a trace, because it basically is tracing exactly what methods called what other methods up until the point that the thing crashed. Again, the first two lines are the most useful because it tells you what happened and where it happened. Line 6 of error1.java in the error1.foo method. Whoops. Okay. Questions on this? You will occasionally see things, if you call, I've actually seen stack traces, and some students in this class have seen stack traces that would be like 20 or 30 lines. Because if what actually crashes is something in the Java SDK, you have all these methods calling all these other methods, and it's going to be a really long stack trace. Anytime you see it, so this is called the stack trace. Let's say it's called a trace because it traces what method calls the other one. It's called a stack for reasons you're going to see in cs101. The thing to remember in this is look at the first line for what happens, look at the second line for where it happens. And I'll see you all on Friday.